Hey, Kevin Ross here. So one of the more common questions I've heard this year is, how can I use a CAD program to model a conveyor belt, a belt with a couple of pulleys? And that'll be the topic of uh, this video plus a couple of others. And I'm going to show you how to make a very nice module where you can actually insert a couple of pulleys and a belt and parameterize it all. So let's go ahead and get started, and I'll show you what I'm talking about. So let's say, for example, that your robot is picking up, say, some rings off the floor, and you built a conveyor out of, say, poly belt. And poly belt is a great little material that's used in industry and in robots all the time. And so here you can see an array of these things. And how is it that you actually build the belt part? The pulley isn't too bad, but the belt part, that actually requires a little bit of moderate level CAD skills. So let's talk about that for a sec. So here's one of those assemblies, and a conveyor has a belt and two pulleys. One of them would be the drive pulley. But the big question is, how am I going to model that belt right there? Well, we're going to go through that right now. And once we get that modeled, I'll show you how you can parameterize it so that you are able to create a library part and create any size belt that you would like. So let's get started. I'm going to create a new OnShape document, and I'm going to call it Kevin CAD Poly Belt first law. And the reason for that is you'll be able to find this later because I'm going to share it publicly. Okay, so here's a start of a sketch. So in order for us, let me give you the rundown on what it is we're going to do here. So this pulley has a few characteristics that we need to know about. One of them is it has a diameter. It's a round pulley belt. And so there's not only is there a diameter, but there's also a distance between these two pulleys. So so the center distance is important. The diameter of the belt is important. And then actually the diameter, or what's called the pitch diameter of the pulleys, is also important. In fact, to make this belt, what we really need to know is the pitch diameter of the two pulleys, the center distance between them, and the diameter of the belt. Those are the variables that we need to work with, okay? So when you look up close at one of these things, so this is the pulley part, and it has a groove to custom fit that belt. This happens to be 3/16, but it doesn't really matter. And the diameter of the pulley, it's called the pitch diameter, and it turns out to be the inside. It's the smallest dimension of the inside. So it's the first point that makes contact. So the pitch diameter is the distance from this point to this point, as opposed to the distance between or the diameter of the outside of the pulley. That's a different number, but it's that point and that point. Okay, so that's what the pitch diameter is. And when you look to see how the belt fits in there, if you think about it for a sec, well, the pitch diameter sort of represents the inside of the belt. Okay, so keep that in mind, because when I start talking about the radius of the belt, I'm talking about the distance between the center of that circle and the pitch diameter. So we have to keep that in mind. So and I'll point that out again as we go along. So let's go into to the CAD program here. This is OnShape, and the technique is very, very similar in any of the CAD programs. I'm just using OnShape because it's a good program. So in order to build that belt, I needed those 2 pulleys, and I'm going to build a virtual version of those pulleys right here in the CAD program. So I'm going to turn on circle and I'm going to turn on construction. And so I'm going to come down here and I'm going to draw a circle here and see how as I come down on this line, see that horizontal indicator just to the lower right of my mouse. That tells me that it's putting in a implied constraint, a horizontal constraint with the center. Okay, so there it is. And for now, I'm going to call this a 1-inch diameter circle. And on the other side, I'm going to do another circle. And for reasons that'll become apparent in a minute, I'm actually going to make this one a 2-inch diameter circle. So I'm using circles of different diameters. Okay. Next thing I'm going to do is I'm going to draw a couple of construction lines. And so this is a construction line, or that's a line, it's in construction mode. And it turns out that before what I'm going to do, I'm going to start on the left side and I'm going to draw a line up and over that pulley. Okay. Then I am going to do another one just like it on the bottom. And you want to make sure that you are above and below and beyond the center marks, because that's important for what we're going to do next. We're going to define a tangent constraint. And you'll want to do the small pulley first, this one to this one. Okay. And I'm going to do the bottom line to there. And now I'm going to do the top line to the big one and the bottom one to the big one. Okay. So what I've got are 2 lines that connect tangentially to these circles. Perfect. That's what I want. What I'm setting up here is a way for us to generate that pitch diameter sized belt. So, all right, I'm switching over to the trim command. I'm going to trim off that line and that line. And then I'm going to trim off this line and this line. Okay, so we're looking pretty good. Now, another thing that I actually do need to do is I need to put in an arc. And I'm going to show you what that is. I'm going to use center point arc, which tells me that I'm going to pick a center point. Here it is. And I am going to pick the end of that construction line, right? So I want that dot right there. And I'm going to extend this around to this dot over here. Okay. Sweet. I'm going to go do the same on the other side. Here to here to here. Okay. And you can see that solid line over there. I'm now done with this. I can turn that tool off. You can see that solid line, and I'm going to do something extreme. I'm going to give this a 6-inch circle. And you can see that the end of our construction line is following that tangent point, and that tangent point is connected to that arc. And that's really important because for this to work, you need that malleability and for it to follow that geometry. Okay, that looks pretty cool. So the other thing I need to do is I need to define the center distance, and that's going to be the center of this circle to the center of this circle. And I am going to say it's going to be 5 inches. Okay. And this number is something that will end up changing later. So now what I could do actually is I could actually take advantage of a feature in OnShape, which allows me to create variables. And I think I am actually going to do that right now. I'm going to double click this guy, and if I hit the hash mark, pound sign, I can call this pulley A diameter. Okay. And it's going to be a new variable. I'll click that, and it's come up and is defined a name and a size, and I'm okay with that. And then I'm going to hit enter. And so this is now pulley A diameter. You can see that has appeared up here in the features window. So that's good. I come over to this side and do the same thing on this side. I'm going to go pulley B diameter. Okay. And I'm going to leave that at 2 inches. That's good. And then down here, I'm going to double click this. I'm going to define a new variable called center distance. New variable. And I can hit that. Okay. And then I'm hit enter here. So now you can see I have these 3 variables, and they are going to allow me to adjust the parameters of this drawing. See, I just changed that to a 2. I'm going to turn it back to a 1 for now, because that's what I kind of want to do. All right. So now let's go back and edit this sketch. So I had to double click on the sketch to edit it again. And as you remember, this is the inside of the or the pitch diameter. So this this shape represents the pitch diameter. What we really want is we need to offset this to take into account that the belt has a diameter to it. So if you'll remember over here, remember this belt has a diameter. The circle that we have right now is to this bottom point on the, or top point on the pulley bottom side of the belt. And we need to define a path in the center of this circle right here, okay? So that's what we're gonna do, is we are going to do an offset command. We're gonna offset that arc, this construction line, and this construction line. And we are going to expand this out a little bit. In fact, I'm going to go out a little extra far. And so that looks like a lovely line. Let's click over here. And now that has become a path. And we need that to be, well, we need another variable for the belt diameter. So I'm going to go # belt diameter. Okay. And that's going to be a new variable. And I'm going to make it 0.125, which is a normal belt diameter, that rather common one. Okay. Now that defined the variable, and so that variable's got a 0.125 in it. You'll notice that this box still hasn't been committed yet, and that's because I now have a variable there. And what I really want is the radius. So I'm going to take half of that. You can see belt diameter divided by 2. And that is the proper radius. Okay. Well, that's looking pretty good. So I'm going to do a couple of things here. I'm going to turn off the offset tool. I'm going to move a couple of dimensions. Move this guy out so that we can read it. Okay. So I no longer need that circle or that circle to be, or arc to be anything more than a construction line. So I'm going to set those to be a construction line. That way they never get in our way. So we have construction lines, and then we have a path. This is actually called a sweep path. And that's what we've designed here, is a sweep path. So before I finish this sketch, I'm going to go rename it. And I am going to call this the belt sweep path. Okay. All right. So far, so good. So we're going to be using the sweep command to make the belt. And the sweep command is going to take another sketch. So it requires a second sketch. And it will take that sketch and sweep it around that path. This outside thing is now our path. And there are a couple of things that you have to set up before that's going to work. One is I need to create a sketch. But to create a sketch, I need a plane that is normal to this line. That means that it is basically perpendicular. The whole plane is perpendicular to this line at a point. And so there's we're going to go up here to the tools, and you're going to find this thing is called a plane, and I can define a new plane. And so here's the plane dialog. And it's and you can set a plane type. There's an offset, plane point. There's a bunch of them. The one we're looking for is a curve point. And what that means is that I'm going to select a curve and a point, and it will make sure that at that point, the plane that we have is normal or perpendicular to that curve. And that's what we want. So the entities that we want are a curve or a line. Okay. It could also be a circle, but we're going to use this line right here. Okay, so that's the one of the chords of that belt sweep path. And then I need to pick a point, and I'm just going to pick this point right here. It really doesn't matter which point as long as you have one. Usually it would be the beginning and the end of a line, but this is a great spot. And if I roll out here, you can see there's this new plane, right? Here is that new plane right there. And I'm going to name it something better. I am going to call this the belt sketch plane for sweep. There we go. So that's a long-winded way of saying that. All right, and you can see it's got its name there. And so now I'm going to make the drawing that we're going to sweep around this line on that plane. So here we go, sketch. And it's asking me for the sketch plane. I'm going to click on that, okay? So that is now where the sketch is. The sketch is now normal to this plane. So I should be able to right-click that plane and do a view normal to. There we go. Okay, now we're going to draw the shape of our belt, which is round. So that's pretty easy. But I need to put it in a specific place for all of this to work. I would actually like this belt to be centered on that point there, so that the thing that I'm sweeping was always going to be centered on that sweep path, okay? So that is what I'm going to do. I'm going to draw a circle, and I'm going to start it on that point. I'm going to pull it out here. I'm going to make it really big for a sec so we can all see it, okay? And now it's allowing me to enter a diameter. So I just start typing numbers, it'll bring up the number dialog. But the reality is I actually want to use the belt diameter variable. So if I hit the pound sign, it brings up all of the variables that have been defined, and I'm going to use belt diameter and hit enter. So there is my belt diameter. So this is now responsive to this variable over here, okay? And that's all I had to do, all right? So I'm done with that sketch. And I am now going to rename this sketch with a rename command. I am going to call this the belt diameter sketch. Okay, so now I've got that circle, and I'm going to do what's called a sweep operation, and that's this guy right here. It's a sweep, and it would like to know what I want to sweep. So if I click on faces and sketches and regions sweep, if I click on that, that's what it's going to sweep. That's our circle. And then the sweep path, I have to select my sweep path. So I can look at this from the side, kind of like this, okay? And I would like it to sweep here. And you can see the belt starting to form already. And so I'm picking that outside sweep path. And there it is. That's all I needed to do. And now I have myself a belt, okay? And it's of a known diameter and a useful diameter. So I'm going to now rename this sweep as belt sweep, okay? Cool. A couple of other things that we're going to do just really quick while we're at it is we're going to come down to, so this created a part. This is a part that can be inserted into into an assembly. So I can come down here to this part, and I'm going to rename it. I'm going to call this a poly belt. Okay. A couple other things I'm going to do real quick while we're here. The material that I'm using is this stuff. It's called polyurethane poly belting, and it's excuse me. I usually get orange. So we're going to do a few things. First of all, I'm going to right click this, and I'm going to do an assign material. And I am going to come down here, and I'm going to look for polyurethane. There it is, polyurethane. That's what the material is. And that'll give me the correct density. Okay. And so when it goes to do weight calculations, it works. And then also under poly belt, I'm going to select this, and I'm going to edit its appearance. And I almost always order orange poly belt. So that's what I'm going to use today, is the nice orange poly belt. There we go. So there is my poly belt. Now, if you'll remember, we have this, I'm going to turn our sketch on. So we have these, we have a couple of pitch diameter circles that represent the pulley, okay? We also have a center distance from here to here, and that's defined here, okay? So pulley A diameter, pulley B diameter, the center distance is defined and the belt diameter is defined, okay? And I can come in here and change these. In fact, usually conveyor belts use the same size pulley on both sides. So let's do that. And you can see it automatically resized, okay? And then the center distance, we can change that. I'm going to make it 8 for now, right? And you can see that everything is resizing quite nicely. So that is how you go about making a poly belt. Not too bad. So that is going to, on the other, so key things, I used some variables in my sketches. That's a super useful thing to do. It makes it much easier to change. Plus, if you'll remember, we had multiple sketches using the same dimension. For example, the belt diameter is actually used both in the belt sweep path in order to define that offset, but it's also used in the belt diameter sketch to set the diameter of the belt, okay? So variables, very handy thing for you to use. And then this whole thing was made using this, this sweep. And actually I don't need that plane anymore. So I'm gonna go ahead and turn that plane off, okay? All right. The other thing that you'll always wanna try and remember to do is when you build a part, take just a quick moment as you're building your part and assign material. And also if you know that it's going to be a certain color, assign that color. It's easier to do that while you're in the midst of this. So that's a great way to do. I'm going to now go to an assembly. So here is my assembly, and I can now go to insert, and you can see in my part studio over here, which I'm going to rename right now, actually. Let's go rename this. I'm going to call this the Poly Belt Studio, okay? So now if I go to my assembly, and I do an insert, Poly Belt, that's the name of my studio, there is a poly belt, and I can click on that and bang, I can place that. And it turns out I can place a bunch of them, right? You can make as many of those as you'd like. All right. Now, I think that's pretty cool. Let me show you. Let me show you a problem that we would probably like to solve. And the thing I would like to solve is that each instance of these things is linked to that original poly belt. And so that kind of makes this not as functional as you would like for a library part. So what would we like to do? Because watch what happens. I'm going to run into the poly belt here, and I'm going to change this diameter to 3, right? So I've changed that diameter to 3, but it turns out that they all changed in the assembly. And in fact, you can only insert this one instance of a part. What you'd really like to be able to do is to be able to insert different sizes of poly belts and be able to fill in a little table, some parameters and stuff to make that work. And that is what we're going to do right now. So that will continue this little thing. You now know how to make a poly belt. Let's go make it so that the assembly is more easier to use. How's that for verbiage? Okay, so just real quick, I'm going to set some of these variables back to a smaller value so that we can see everything. And I'm going to change this guy back to 5. Okay. So how can I make it? Well, it is possible to make it so as I go to insert something, all of these parameters are things that I can define. So here's how that works. I'm going to open this tab. See this configuration panel? This is super cool. So the configuration panel will allow you to do all sorts of cool things. We're going to start by getting a belt diameter. Okay, so that's the first thing we need to know. So I am actually going to use this Configure Part Studio window, and there's three things you can insert: a list, a checkbox, or a variable. So a list will allow me to select from a list of potential values. A checkbox is an on off. I can either say, yes, it's going to do this, or no, it's not. Or I can put in a configuration variable, which will allow me to type any number I want. Okay. Well, in our setup here, we actually have center distance isn't really, we need somebody to be able to type in a center distance. So let's do that. So let's put in a configuration variable, and I'm going to call it center distance. Okay. And the default is 1 inch. I'm going to change that to 5 because it just makes me happier. Minimum distance, well, 0. I don't know what would happen if you typed in a 0. I think the sketch might break. So I'm going to say 0.0625 because who knows, you might make a really, really tiny thing, but I have a feeling 0 is going to cause some problems. So, and then the maximum, I don't care what the maximum is. Okay. So there we go. Now, if you noticed up here on the left under configurations, there's now a center distance variable, and it's currently set to 5 inches. Now there's also a center distance variable down here. And it turns out that I can actually delete this one. In fact, actually I need to delete this one so that this upper one takes over. So I'm gotten rid of center distance down there. And now whenever I change this number, this belt changes, okay? So that's good. Then I've got a couple of pulley diameters here. Well, I guess I'm going to do the same thing. So I'm going to come down and I'm going to add a configure input, and I have another variable, which I would like to say pulley, misspelled it, a diameter, and default's 1 inches. That's fine. Again, I don't know what's going to happen if somebody types in 0, but I'll point 0.0625 sounds good. We'll make that as a minimum. And I guess that's all there is to it. Now I could have selected other things. You can select to have an angle, an integer, a real number, or a text, but we like a length because the length will get defined in some units. It turns out that when somebody types in, you can type in other units here. You could put in millimeters if you want, and that does work. So there's a pulley diameter A. In fact, actually, I'm going to do that for pulley diameter B as well. Do the exact same thing. Pulley diameter. Oh, pulley B diameter is really what I wanted. Pulley B diameter. Pulley B diameter. I spelled it correctly. All right. So now you can see I can drag this down a little bit. Which we now have these 3 parameters. So I should be able to get rid of this variable and this variable. And look, I can now make this thing 25 millimeters, or I can make this thing 1.5 inches, right? And so yay, that's looking pretty good. So the last one is the belt diameter. Well, belt diameter is a little bit more of an interesting thing for us to think about. It turns out that there are a fixed number of belt diameters. So I'm going to go over here to our friend McMaster Carr, and I'm going to look for polyurethane, ethane. Gotta be pretty impressed that I got that. So let's see, what am I looking for? I'm looking for round belts. Here they are. These are round belts. And here it is. There's the orange ones that I normally order. And there are a fixed number of values that I could pick. Okay. So I'm actually going to go and I'm going to look for round belt. And I actually want round belting. I think this is my friend. Yeah. And here are the sizes. There's a fixed number of sizes. And it turns out that once you get up to a 1/4 inch on our robots, going over a 1/4 inch doesn't really help all that much. But you could, in fact, actually, I could put in all of these values if I wanted to. And that might be something that I'm going to do. And so and in fact, I believe that is what I'm going to do. And it turns out that I have in a spreadsheet, here I'm dragging this spreadsheet over here. I actually had 3/32, 1/8, 1/4. I'm missing 3/16. Oh, I lied. Never mind. Well, it was a good start anyway. So what we'll do is we'll end up adding in all of these values. So I'll show you how that's done. Okay, so I am going to do a list, and I'm going to name this list belt diameter. Okay, and there's a list here. Now it turns out that I can actually drive any parameter in any of the sketches anywhere. Okay, but it turns out that since this belt diameter is used in multiple places, I am actually going to drive that. I am going to drive that value from here. So what I can do is I can say configure features. Okay, and so that's configuring this feature. And what it's doing is it's asking me, go find the things that selecting one of these changes. So it's going to be belt diameter, and I want to change its value. And see how that turned yellow up there? So if I click on this, you can see over here that belt diameter is now associated with whatever this name of this thing is. So that's what I wanted to see happen. And I'm going to click on done. So now I'm looking at our belt diameters, and I can put in 3/32 of an inch, and that will be 3/32 of an inch. Okay, so remember, this is a name, it's just a text string. The value on the right is actually a length or a value. And so I'm going to just, we'll just go really quickly, 1/8 of an inch, and this needs to be 1/8 of an inch. And there's also going to be 3/16 of an inch. And I will change this value to 3/16. And this one will be 1/4 inch. And you get the idea. And we almost never go over 1/4 inch, but I might use 2 millimeter. So I can mix my units, because again, it's just a name. And since this is a known, this is supposed to be a length, or it has units, right? And then over here, I'm going to go 3 millimeters. And I'll make this one 3 millimeters. Oh, actually, I take it back. 3 millimeters wasn't a choice. That should have been 4 millimeters, right? Okay, so 4 millimeters. So that is okay. Now, if you look, you can see all of this, right? If you look up here on the upper left, I'm going all the way up here to configurations. You can see that belt diameter showed up, and it's got a little drop down box that'll allow me to pick belt diameters. And as I change these, you can see that the belt diameter variable gets changed because of this configuration. And I can make this belt whatever size I want. Pretty cool. I'm actually going to default. So the other thing you can do is I can set a default value here by finding the row I'd like it to be and right click it and say set as default. Okay. So if I put this away, I now have all of this cool stuff. Actually, I'm going to open this back up. I think what I'd like to be able to say is I would like to put belt diameter all the way up to the top. So I can move it up you can see me moving it up, and you can see it getting taller over here on the left. Do it one more time. I'm going to hit move up, and you'll see it show up at the top. So we're going to have belt diameter, center distance, pulley A, pulley B. All right, that's pretty cool. So now what do I have? Well, now if I go over here, you can see that each one of these belts now has a little configuration data packet that goes with it. So each instance, each belt that I insert can have its own values. So I'm going to go ahead and delete these guys, okay? So even the belt that I started with, which is poly belt 1 here, I can do a change configuration on it, and let's change it to be a 3/32 with a 4-inch and 2 1-inchers. Okay, so I can change all this, and then I can do a generate, and there you go. It's a much smaller belt now, and I can insert another poly belt. See it here? So now when I go to insert it, I can enter all of these parameters. This is just like super useful. I can enter these parameters, and I can tell it it's going to be 6 inches, and I'm going to use 2-inch belts. Okay, and it'll generate it, and I can insert it, right? And I'll put it right there. And so each one of these is independent and has its own parameters. Now we're starting to see something useful, because I can actually now build myself a custom size belt, and each instance has its own parameters with it. And even if I put this in a library file somewhere, I'm able to change those parameters on the fly, and that's going to be like super useful. Okay, hopefully that made some sense. Well, cool. I think that is a pretty miraculous piece of work right there. So that's how you make a poly belt. Well, let's go back to that other example. Now that I've done that, wouldn't you like to also be able to make the custom size pulleys to go with? For example, I actually made one. It is, you can see it here if you look in my little window there. Well, anyway, I can actually 3D print these, and that's what I did. Is I managed to 3D print these pulleys, and I went over a little overboard on mine. There's all sorts of features that you can actually do to these, and just as a preview, because I'll show you how to do this. If I go to like one of these pulleys and change its configuration, I can do all sorts of things. I can change the hole. Say you wanted to have a 3.75 hex, and and you can generate that. And so look at that changed that guy to have a hex bore. Or what if you wanted a D shaft, so you could stick it right on the end of a motor? See, there's a little D shaft that'll fit right on an Andy Mark motor. So there's a big selection of different sizes of shaft holes and hex holes. So and all of that is configurable. So I think that it made it pretty easy to generate a little guy and to be able to 3D print your own pulleys. So let's see if we can build another part studio in our poly belt example and make a configurable pulley. So that could be pretty interesting. So that's going to be the next section of this video. So let's get at it. So back in my poly belt, assembly 1 here is really just test parts. So, but what we're going to do is we're going to insert a part studio. Okay, and I'm going to move it over here to the left, and I am going to call this a pulley. Okay, so let's go take a quick peek at a pulley. So here's a wheel and a pulley, but here's a pulley all by itself. Move it up here. So it has a body that has a pulley shaped, a very unique outline to it. it has, you know, it comes up to some radius, and then it has a slightly less than a half circle. If you look, it doesn't quite get all the way up to the halfway point, but that's okay. When I went looking at these pulleys, the commercially made ones, it turned out that they all stopped about 5 degrees short of being a half circle. So, and they picked 5 degrees. I just so that it didn't close off on the belt, so that the belt could slip in and out if you needed it to. So we're going to do that. And also notice that there's the half circle comes up and it ends, and then there's a straight line. So so it's kind of like got it has a kind of a groove to it that extends up. The little groove goes from here up to there. Okay, so we're gonna take that into account. The other thing I found, these pulleys all specified, the ones that you can buy all specify a groove depth, which is from the top of this down to this point, and that's actually the pitch diameter. So from there down to the pitch diameter is called the groove depth, and so we're going to take that into account when we go to build ours. All right. So other things. Well, so a good way to do this is to actually draw the outline of this thing, or draw the profile of it, and then take that two-dimensional drawing and rotate it around an axis. That's what happened here. Is there's a drawing for this guy, and we rotated it around that axis in order to generate the solid. So that made sense. I'm going to actually change the configuration so I can talk about one other feature that we're going to put in. I'm going to make this into a round hole. Let's go with a 1/4 inch round hole. And I'm going to hit generate. So you can see now this has a 1/4 inch hole. And I like to 3D print a lot of this stuff. And it turns out that if you have much experience with 3D printers, sometimes they don't actually generate exactly perfect parts. Actually, let me put that more succinctly. Most 3D printers, unless you have like a Mark Forge or a very good commercial 3D printer, there's going to be some errors in things like hole sizes. And normally it doesn't matter, but here you want to be able to like fudge that number a little bit. So what I did is I put in another variable called a 3D print bore adjustment. And when we get to that, I was thinking ahead, and that way, if I need to, if I print one of these test parts and find that the hole is too big or too small, I can add a little offset adjustment here for that. So that's my plan. Okay. So we have the parameters then for us are the pitch diameter, and that's the distance from the center to that inside to where the inside of the belt is going to touch. We have the belt diameter, so just like specifying the belt itself. And then we need to decide whether we want a set screw hub. And so if most of the times you're going to want one of these because you want to be able to attach it. If you're using hex and you've got spacers and stuff, that might be a different story. But but this can be turned on and off. So if I turn this off, for example, you'll see that hub disappear. Not exactly what I want right now, but I want to be able to control whether you get a hub. There might be reasons for not having a hub. The size of the set screw could be important to you, so I allow you to choose from a list. And then the bore of the shaft, I put in all of the standard FRC axle sizes because I had to happen to have them in the spreadsheet. So these are the common ones. And so I figured, oh, what the heck? We'll just we'll put all of the common shafts in there and see if we can make use of that. And then that print bore adjustment. So those are our parameters. Okay. Hopefully that didn't bore you to tears, but that's where we're headed. We're going to be able to completely configure one of these. All right. Cool. So I'm just going to save that change. So I'm going to go back to our poly belt example, and we're going to start a drawing because that's what you do when you make parts. So I'm going to put it on the top plane and I'm going to look at the top. Now, I think the first thing we're going to want to do is we're going to have a pitch diameter. Okay. And if you'll remember from our previous uh, the previous thing where we did it with the belt, the pitch diameter is from this. The pitch diameter is the smallest circle around the pulley. And so that's what we're going to start with. We're going to go from here, we're going to go up, and I'm going to want somebody to be able to type in a number. So I'm going to define a variable for this. So that's it. And I want this to be pitch diameter. Okay. And it's going to be a new variable. Now, this little new variable dialog, if you wanted to have a configurable feature, you can actually do that from here by, instead of hitting feature, hit configuration, right? And we're gonna make it default to 1, and we're gonna also give it just a very, very, very small minimum, so it isn't 0. And there you go. And when I hit this, you'll see that pitch diameter showed up as a configuration up here. And it's actually allowing me to enter a formula. Well, what we're doing is we're doing the outline of we're doing the outline of our part. So I actually want this to be the radius, and you'll see why. So I'm going to divide this by 2. Okay. So that is actually the pitch diameter radius, if you will. Okay. If you remember looking at our profile here, from the center here, we need to go over and ignore the hub for a minute, but I'm going to go over, up, over, down, and then around to the center and back down. Okay. And actually, I'll end up mirroring that on both sides, but we're drawing this quadrant right over here. Okay. So that means I'm going to need another line, which is from here over, and then it's going to go up. Okay. And then it's going to come over a little bit. In fact, actually what I'm going to do is I'm going to drag this over here a ways, and I'll just stop it there. And you'll see why I did that in a sec. Okay. Now, we need to know the belt diameter. Well, let's make it match our poly belt. So if I go over here, and here's belt diameter. Well, it'd be nice if it matched that other one. So this doesn't live update, but I can come up here and I can say copy table. So that'll give me belt diameter, right? So now I'm going to go back to the pulley, and I'm going to pull open the configuration tab, and I am going to oh, I have to stop the sketch for a sec. That's okay. We'll come back to it. If I stop the sketch, I can come over and add a list, and I can click up here, and I should be able to say, whoops, I should be able to say somehow, in a sec. Well, I messed something up, so we'll try it again. So this is going to be belt diameter. Okay. And that by default is its variable. This is actually the text that goes in the configuration. Okay. And it's going to be a list. So you can see that's that text over there. And I'm going to go try that again. I thought I copied this table. So I should have done a copy table, belt diameter table copied to clipboard. If I come over here, I should be able to paste it. And it's not letting me paste it, and I don't know why. Oh, well, I think I can actually just hit Control V. Oh yeah, there it is. Cool. So, all right. It is complaining at me because I did not give it a feature to configure. So, oh, because I forgot to define. Okay, sorry. Configure features. See, hey, look at this. You can watch me kind of mess up. So what I really needed to do is I needed to define a variable for it to change, and I forgot to do that. So we're going to edit the sketch. We're going to we are going to come over here, and we are going to put a point because that I needed a point up here anyway, and that point is going to be vertical with that. And I'm going to define the distance, which is going to be distance from here to here. Sorry about that. I forgot to do something first. So we're going to define a new variable. And that new variable is going to be called belt diameter. Okay. And I'm going to hit OK. There it is. So now it's not going to be the belt diameter. It's going to be the pitch here again, right? We want half that distance. Because remember, this is where the belt hits the bottom. This is where the belt center is. Okay, so now if I come over here to where it says configure features and I click on belt diameter, I want to be able to change the value of belt diameter. And you can see over here, belt diameter has appeared. So yay, that's what we wanted. And so I'm done with that. And if I go back and copy that table again, here it is, copy table. And I go back over here and I'm going to click there and I'm going to hit Control V. Right. Cool. There's the table. It turns out I really don't want these. I actually don't want this row. I'm going to delete that row. And then I'm going to come and I'm going to switch to this guy so I can come up here and delete this row. There we go. So now I have my diameters, same as the belts. Okay, that was a bit of a detour, but sometimes you got to be able to recover from your mistakes. So let's pull out here. So belt diameter is actually going to affect the distance between these 2 points. So if I change it to something big, you can see that it moved. And if I set it back to something reasonable, like 3/16, there it is. Okay, let's go back and edit the sketch again. So I'm going to draw a construction line, and it's going to go from here over to here. Okay, cool. And I'm going to actually draw another line from here down to here. Okay. Now, if you remember, I've told you about this 5-degree extension up here. So this comes up and it stops, and then it heads off at a 5-degree angle relative to the pitch diameter. So we're going to do that. So I'm going to dimension an angular measurement here and call it 5 degrees. Okay. Now I'm going to do a center point arc from the center of our belt down to the top of the pitch diameter, and it's going to come up and intersect that 5-degree line right there. Okay. That's where our 5-degree part is going to end. Okay. Then I need to set the height of this. Well, that is another variable that was the depth of our. Remember, I told you earlier that groove depth was a variable that when you look on the McMaster-Carr website at their pulleys. So let me go find round belt pulleys. There we go. If you look, they have the belt diameter And then they have some information and about the outside diameter of the pulley for a shaft size, and what the pitch diameter is, and what the width of the pulley is. And then it has groove depth. And it turned out that as I was looking at this, I was realizing that it basically added about 0.2 or 20% of the belt diameter to the groove depth, and that's pretty close. So like here, 3/8 belt, half of 3/8 is 1.875. So they added that 10 to 20%. I think it must be 10%. Yeah, they added 10%. Here they added 0.125. Yeah, they added 10%. So we're going to add 10% about, okay? So but we need a variable to define that. So we are going to do a dimension between the pitch diameter and the very top of the pulley, okay? And I'm going to define that as groove depth, okay? And that's going to be a new variable. And it's actually, I don't need it to be a configurable variable because we're going to put it in a table. You'll see that in a minute. But in general, I guess at the moment, what we'll go with is belt diameter times 1.15. How's that? And I'll hit enter. And actually that's, so here we have a 0.1875. Actually, I think I'm going to change that. I'm going to change the definition of this to be 1.1. There we go. That's what I want. Why did I do that? Because that is what was going on here. So the groove depth on a 3/6. Well, anyway, that's kind of what I wanted, but I needed to take the groove depth, needed to be the belt diameter divided by 2. It needed to be the circumference. That's where I went wrong. There we go. So it wasn't a lot. This is what I was looking for. It shouldn't have been a lot. Okay, so where are we? We've got the start of the profile, and we are going to keep on the sketch here. We're now going to extend this up to this line. Okay, cool. And I want these two lines to be perpendicular. So I'm going to make this guy perpendicular to this guy. So now that line sort of heads off. And I'm now going to trim this because its length will be defined by something else. So we're getting close. But we do need we now need to define the width of the pulley. And so that is going to be this dimension here. Okay. And this is going to be pulley width. And that's going to be a new variable. And I want it to be belt diameter. And actually, I'm going to divide that by 2. So it's really belt radius. And then I want to multiply that times I think 1.5 ought to work. Let's see how that does. So I believe that's a great number. I like that number. And yeah, that looks reasonable. And we may need to fudge with that a little bit later. All right. So what we have here is we have 1/4 of the profile. And again, it sweeps up. It goes a little bit beyond at a 5-degree angle to sort of open up a little opening for the belt to fall into, and it'll probably prevent it from falling out. So with that, I am now going to do a mirror against this line, and I want to mirror everything. There it is. And there's my drawing. Okay. That is my outline. So with that, what I really want to do is I want to now revolve this around an axis. So I'm going to take these guys and I'm going to select this axis, and there is our pulley. Okay. So let's go get in there and take a quick look. You can see that it comes up half round, and it's got that little extension there at the top, so that the belt will just kind of fit right in there. So that's nice. That's very nice. And it'll change as I change the thickness, right? It seems to be commensurate with that. This doesn't look like a 90-degree angle here, does it? I think I got a problem. Okay, so I'm just looking at that, realizing that that wasn't a 90. So that means I just need to go back in the sketch and let's go figure out what's going on there. Oh, I see what's happened is that it got cut off here, and I don't know why. So we need to edit a few things. We need to, we actually want to trim these two and these two, because we don't want that. Okay. Then we want this and this both need to be construction lines. There we go. That's the profile that we're looking for. Okay, see, and that made that straight again. And and there we go. And that sketch, so that's a good profile. And again, we'll change it up to a bigger one to make sure it looks right still. Yep. All right. So that is a nice configurable pulley that we can make. Now, what else do you want? So we now need to think about that the bore and the hub. The bore and the hub, those are important. So let's think about that for a minute. Well, the bore and the hub. If you look at this thing, the hub definitely always needs to be bigger than the bore. And so the important number for us to keep track of is what is the diameter of the borehole. Okay. So the reality is that we need to base that hub based on the borehole and take into account any unique features in here. So it feels like a table to me. So if I select a bore diameter, I'm going to end up with a hub diameter that's bigger for sure. And then I also want to be able to select the set screw size, because the set screws, I don't know, just seem like something I would want to be able to set. Okay. So I guess we're going to start by allowing somebody to pick the bore. Okay. So now there are a couple of ways we can do the bore, and we want to be able to do a round bore, a hex bore, and a D-shaft bore. Interesting. Well, two of them are based on rounds, and then there's another one that's not. So we'll figure that out. Okay, but let's start with the round ones first. So this sketch is, okay, so I want to unselect everything, clear selection. I want to take this guy and rename it. This is the pulley sketch. Okay. And well, I'm getting fumble fingered here. Pulley revolve. Oh, and by the way, this thing is going to be a pulley. Okay. I need a new sketch and I am going to put it on the top plane. Okay. And now we're going to look at it. We're going to view normal to. Oh, I lied. I wanted it on the right plane, apparently. Oh, right. Okay. So, actually, we're going to sketch on this face. There we go. Now we're looking. There we go. So I'm going to draw a circle because it's a round bore. And I'm going to type in the bore diameter. And that's going to be a variable, and I'm going to default it to 0.25 inches. What do you think of that? All right. There's a bore diameter. Now, so I have a bore diameter, and I guess I can actually just go ahead and extrude that because it's going to make a hole. So we're going to do an extrude of this thing. And it is going to go all the way through all. And it's going to be a remove. And there we go. So there is our, there's a borehole. So we're going to add some parameters to it. But we're pretty sure it's going to go all the way through. And actually, maybe I didn't really want to do it that. Yeah, I'm going to take that back. I'm going to go change this sketch. And I am going to erase that. I'm going to erase that thing. I'm editing the sketch. There's the circle. Delete it. There we go. Actually, let's do the hex first, and I'll show you why we did the hex first. Inscribed Polygon. Here we go. If I follow this out along the axis, and I do 6-sided, there it is. And I can actually do a diameter. See that? I can dimension this diameter, and I can make this equal to bore hole diameter. Bore diameter. Yay us. Okay. So there's our bore diameter, and there is our polygon. And actually, what I should be able to do now, if I turn the dimension off, I should be able to turn this circle and make it not a, it's no longer a construction line. You'll see why I did that in a sec. Okay, so I'm going to hit OK on that. And now I end up getting this extrude. Okay, cool. So my choices are I can extrude this. So this is the bore hole hex extrude. Okay. And it'll be able to do both, and you'll see why in a sec. Okay. Now I need to do a table because there's going to be a set of possibilities for boreholes. So let me bring this over, and I would like to now have a new list. Okay. Okay, so I have a spreadsheet that I did before, and it has over here, it has sizes that I would like to use. So this is the list of sizes that I used in that other one. And so what I'd really like to be able to do is I would like to do these. I want to be able to copy these. Now, it turns out you can copy and paste values out of a spreadsheet into a table. But what I need to do is I need to have that shaft size first. So what over here, I'm going to do configure features, and I want to be able to adjust the bore diameter's size. Done. Okay. So now, if you remember that list, I just copied it, and over here, I'm going to paste it. There we go. So these are all the sizes that you could pick. Yeah, that works. And then I'm gonna get rid of this untitled one. Delete that. Okay, so I have 1/4 inch D shaft. I have 6 millimeter D shaft, 0.5 hex, 0.375 hex. I'm gonna go 0.500 hex just because to match. Okay, so there are all the bore diameter sizes. And if you watch me play around up here with the bore diameter, here we go. I can change these and they will start affecting that shape. Well, but they're all hex. What I really want to be able to control the roundness. So I want to configure something else. What I'd really like to do is I would like to be able to configure the bore head extrude, and I want to change the selection, and yeah, I should be able to change the selection. So now if I double click on this, I would be able to pick just the inside circle, and that should work. Okay. And if I now select 3 millimeter round, that sounds like that's actually a pain in the butt. So let's not do it this way. I'm going to undo a few things. Let's go do it a different way. I'm going to rename this guy into bore hole extrude. Okay. And this guy is actually going to select the hole. There we go. And then what I will do is I will also create a new extrusion from this sketch, and I will pick the hex shape. So this, whoops, in a sec, we're going to do this, that. Hang on a sec. I'm doing something wrong. Oh, I need to suppress this for a sec. There we go. Extrude. Remove. There we go. That's what I wanted, is that hex shape. Okay. So this guy can now be unsuppressed. If I suppress this guy, it should get a circle. There we go. Okay. Bore hole, bore hex extrude. So I would like now to have another configurable feature, which is whether the hole extrude is suppressed. Okay, so that's one thing. And I would like to have another feature which tells me that this guy is, that one is suppressed. Okay, so I'm controlling the extrusions independently here, whether they actually happen. So it turns out that I can actually make, I'm going to I just changed all those values based on what I had in this spreadsheet over here. Sorry about this. This is a little weird, but it's all good. So now the hex extrude is suppressed or unsuppressed only on round holes, and the hex extrude is only unsuppressed on hexes. Okay, so let's go watch this in action. So if I say I want a 1/2 inch hole, that works. If I say I want a 375 hex, that works. 5mm hex, that works. Okay. Cool. So that's working. So we can now select the hole size. Now I kind of want to, I'd like to be able to figure out what the size of I want to figure out what the size of the set screw hub is going to be. And I suppose I could stop here. I'm going to stop now and figure that out later. Okay, I'm going to finish this later.